Alright, hi everyone. So I started recording yesterday and was going to do the acidic and basic conditions, and then I had done this basic condition problem and I got it all wrong. So I went back and I edited the video, I cut that out, and so now I'm going to show you how to do the basic one, and we'll tack some more stuff onto the end of this video as well. So listen, in this balancing in basic conditions, it's going to look the same as in acidic conditions. We're just going to have to balance out the H pluses with hydroxides in order to make it in basic conditions. And so the first thing that I want to do, which I started to do in the last video, but of course you didn't see because I cut it out, was I just went through and I assigned the oxidation numbers to each of the elements. If you want to take a second and pause the video and do that on your own, you can. I also identified in green what was oxidized and in orange what was reduced. So now what I'm going to do is I'm going to write my half reactions, and I'm going to go from Cr plus 3 to CrO4 2 minus. And so when I do that, I'm going to have my Cr plus 3 goes to CrO4 2 minus. Now from here, what I'm also going to do is I'm going to now balance for the number of oxygens using water. So I'm going to have plus 4 H2Os on the left. And then I'm going to balance for H pluses on the right. So I'm going to do that to balance the H's. I'm going to have 8 H pluses. Now I could put in electrons now, or I could wait. It's really up to you. You'll get the same number of electrons whether you do the hydroxides first or whether you do them later. So we can do the hydroxides next, since that's what's step number 6 up there. So now I would add 8 OH minuses to each side. And what I would get is this. I would have on the left 4 H2Os plus Cr plus 3 yields Cr, sorry, let me erase this, Cr plus 3, and I'm going to add the 8 hydroxides to both sides. So I'm also going to put the 8 hydroxides on this side. So we're going to have plus 8 hydroxides yields CrO4 2 minus plus 8 H2Os. Now you can see I have water on both sides, and I can cross those out and simplify this. So the 4 waters will cross out with the 8 waters, leaving us with 4. And we'll have Cr plus 3 plus 8 OH minus yields CrO4 2 minus plus 4 H2Os. Now I need to go through and I need to check the charges. And so on the left I have plus 3 from the Cr, minus 8, so that's minus 5. And on the right side I have minus 2, so I'm going to add my 5 electrons. I'm sorry, it's minus 8. No, that's not right. I'm going to have my plus 5, my minus 2, I'm going to have my 3 electrons. Thinking 5, but it's really 3 electrons. So now this is my balanced half reaction for the chromium part. And I have my 3 electrons, I have my 8 OH minuses. Now we have to go through and do the same thing with the chlorate. So now let's go and do that. So we're going to have our ClO3 minus yields Cl minus, and I go through the same process. Need to add waters, so 3 H2Os, and then I need to add the 6 H pluses on the left. And then I also need to put in electrons. So on the left, actually we'll do hydroxides first. So I need to balance out the hydroxides, and so then I'm going to need to add 6 OH minuses on the left, and I'm going to add 6 OH minuses on the right. And when I do that, I'm going to get my 6 waters on the left plus my ClO3 minus yields my Cl minus plus 3 H2O plus 6 OH minus. Once again, I can simplify with the waters and add in the electrons. 3 will cross out with 6. That will leave me with 3 H2O plus ClO3 minus, yielding Cl minus plus 6 H2O, 6 OH minus. And then I can count up the charges. And when I do that, on the left side I have minus 1, on the right side I have minus 7, so I need 6 electrons on the left. So now I have my 2 half reactions, and I put them in blue, and those are the 2 that I want to add together. But before I do that, before I add them together, I need to make sure that, in fact, I have the same number of electrons being lost and gained. And so I will now multiply the top reaction by 2. So when I multiply the top reaction by 2, I'm going to do that in this nice blue color here. I can put that down below, and I'm going to get 2Cr plus 3 plus 16 OH minus yields 2CrO42 minus plus 8 H2O plus 6 electrons. And so now I can go through and I can balance them and cross out the like terms. I can see right away that the waters, those are going to cross out, and we'll cross those out in yellow here. The 3 waters will cross out with the 8, and I'll be left with 5. And then the OH minuses, 6 of them will cross out with 6 over here, and we'll be left with 10. And then the 6 electrons will cross out with the 6 electrons, and now we can just put these together, add it up. We'll do a different color. It'll look a little bit better. On the left, we're going to have our 2Cr plus 3s. We're going to have our 10 OH minuses. We are going to have our ClO3 minus. On the other side, we are going to have our 2CrO42 minus, our Cl minus, and our 5 H2Os. And now we're going to hope that we did all this for a worthy cause, and that is to actually balance a redox reaction. So let's take a look. So on the left we have 2 Crs, the right we have 2 Crs. Left we have 10 O's from the OH and 3, so 13. And on the right we have 8 and 5 is 13. On the left we have 10 H's, on the right we have 10 H's. On the left we have 1 Cl, on the right we have 1 Cl. Now the charges. On the left we have plus 6 from the Crs. We have minus 10 from the OH, so now we're at minus 4. And minus 1 from the ClO3, that's minus 5. And on the right side we have minus 4 from the CrO4s and minus 1 from the Cl, that's also minus 5. Hey, guess what? We balance this reaction and we're done. Now, you can imagine I took the same amount of time yesterday to do this reaction on that other video, and it didn't work at the end. And I had to go back and I had to actually redo that. So let's tie this all together here. So we're going to have putting together the redox reactions. These are for the simple ones. You always want to look and assign oxidation numbers first. You want to look for elements changing from pure elements into compounds. You want to see and know that reduction is when you gain electrons and you'll become more negative. Oxidation is when you lose electrons, you'll get more positive. Remember that you can use the mnemonics Leo goes Gur to help you. The reduction is going to be when you put the electrons on the left side of the half reaction for reduction, and oxidation, put it on the right side for the half reaction. We did a lab with table J where we compared the activity of different elements, and this would apply to all of these redox reactions. Specifically when we're doing something like a single replacement, it is really, really useful. And so what we're looking for is, if we look at table J, when we have a metal and we are replacing another metal with that metal, we want to have the one that's on top here being oxidized. If you look on your table J in your reference table, it will not have the word oxidized. I wrote that in, and that's important that you understand that the element on top needs to be oxidized. The element on the bottom that's less reactive will be reduced. Now, if we look at the nonmetals, though, they're opposite. The metal on top should be reduced. The metal on the bottom should be oxidized. Now, why do I care about using table J? Because it helps me to figure out if a reaction will actually occur. And these examples down here actually help me to figure out if a reaction will occur, if it'll be spontaneous. Let's take, for example, something like K and Ni plus 2. If I react K plus Ni plus 2, the K will be oxidized. It can't be reduced. You never see K negative. You look on the periodic table, K is in group 1, it's going to lose an electron. So K should become K plus. Well, if K becomes K plus and it was oxidized, the Ni has no choice but to be reduced. It had to gain electrons from that K. So now, let's take a look and see if this happens. I didn't balance this at all. We can go back and balance it. But, let's go see if it actually works. So I want to identify these two elements, K and Ni, on the not periodic table, on table J. So I look, I find K, and I find Ni. Now K is up higher, so K should be oxidized, and it is. Ni should be reduced, and it is. Let's look at that again. K is oxidized. It becomes K plus. Ni is reduced. It goes from +2 to 0. This reaction will occur. If you put potassium metal in a solution, this is aqueous, this is solid. If you put a solid piece of potassium in a solution of nickel, it should work. So let's do one more, and then you could try one on your own. Let's try this one here, cobalt plus Al plus 3. So if I react these two together, I will get cobalt and aluminum. Well, cobalt has no choice. It's a metal. It's going to be oxidized, not going to become negative. Aluminum also can't be further oxidized. It's lost its 3 electrons. If you look in the periodic table, you can see that aluminum has a maximum charge of +3. So aluminum will become Al. Cobalt, its charge is +2 or +3. We'll make it +2. We don't really know if it will be completely oxidized or not, but let's see. So cobalt is oxidized. Aluminum is reduced. Let's take a look at the table. Let's use a different color for these. We'll use a nice pinkish purple here. And we're going to see cobalt and aluminum. Let's find them. Cobalt and aluminum. Aluminum, what should happen to it? Well, it's higher up. So aluminum should be oxidized. Copper should be reduced. Let's see if that's what happened. No way. Aluminum was reduced. Copper was oxidized. That's not what should happen according to Table J. Aluminum is more active. It should be oxidized. Copper is less active. It should be reduced. This reaction doesn't happen. Try the next two. Go through and do them. They have HCl here. You might be wondering what's that about. You're going to compare that to H2. That's going to be a reaction with an acid. So give that a try and see if the metal is above or below that and what happens. Okay, you could try the non-metal ones too. These are good to try. Remember, the metal on top should be reduced. The non-metal on top should be reduced. The non-metal on the bottom should be oxidized. I write it on the table right over here, reduced, oxidized. Now, next time we'll do electrochemical cells and talk about that. All right, thanks so much for watching.